equation y prime is 2x, you would tell me that y is x squared plus c, right? If y prime is 2x, y had to be x squared plus a constant. Well, it's the same situation here. The derivative of this thing is log x. So this function here, x cubed y, must be the integral of log x, which I'm telling you is log x minus x plus c. Then divide by x cubed to get y. And there's the general solution. This is how you do it. xy prime plus 2y, oh my God, geez. But it's linear, right? It's not in standard form, but it is linear. Because if I divide through by x, I got y prime, 2 over xy is 2 over x square root x squared minus 1 minus 2x. I divide it through by x. Now it's in standard form. It's linear. Now written in standard form. I'm just going to blindly go ahead, right, and hope for the best with respect to integration. We multiply by e to the integral, multiply by e to the integral 2 over x dx, which is e to the 2 ln x, which is e to the ln x squared, which is x squared, property of exponential log functions. So we get x squared y prime plus 2xy is 2x over the square root x squared minus 1 minus 2x cubed. I multiply through by x squared. Now the left side of this equation is x squared y prime. Check. First derivative, second, that's this term, plus the second function, y, derivative of x squared, 2x, is 2x over square root x squared minus 1 minus 2x cubed. So, x squared y must be the integral. 2x square root x squared minus 1 dx. Got the 2x cubed. Minus 2x cubed dx. Can I integrate that? Yeah. You have confidence in me that I can? And I can. This says, oops, here, I can lower this down. This says x squared y is, what is this term? This is u to the minus 1/2 in it. If you put u equal to x squared minus 1, du is 2x dx. So this is u to the minus 1/2. The integral u to the minus 1/2 is u to the plus 1/2 divided by a half, which is times 2. So this is 2 square root x squared minus 1 minus 1/2 x to the 4th plus c. So y is equal to 2 square root x squared minus 1 divided by x squared minus 1/2 x squared plus c over x squared. General solution. I just want to go back and check one thing here. Yeah, okay. Here's the general. I want to make sure that I divided the c by x cubed. Okay? What I'm saying is here, I get x squared y is this stuff, and then I divide by x squared. Some people forget to divide the c by x squared. I divide everything by x squared. This is a multiple choice kind of question, by the way. And sometimes we will write one of the choices like this. That's a tragic mistake, right? If you chose that. I'm dividing through by x squared, I got to divide everything by x squared. Yes, ma'am.
Is it the previous line, is it 2 to the x cubed minus 1?
Which term?
The previous line.
Right up in the top.
Yes.
This line right there. What's wrong?
What's up in
X squared minus 1 or x cubed?
X squared minus 1. Wasn't that what it was? X squared, yeah, x squared minus 1. This is x squared minus 1. I put u here equal to x squared minus 1. So this has the form u to the minus 1/2. The integral u to the minus 1/2 is u to the plus 1/2 divided by half, which is times 2. All right. Let's see where we are here. Number 10. All my previous examples, had this, where did we start here? Kind of x y prime or x squared y prime. Divide through it to put it in standard form. Well, there's a variety of possible expressions. Y prime cotangent xy equal 2 cosine x. And I want to solve an initial value problem. Y is pi over 2 equals 2. How do you solve initial value problems? Step 1, find the general solution of the differential equation. So we look at y prime plus cotangent xy equal 2 cosine x. We want to solve this. That is finding the general solution. So we multiply by, this is already in standard form, e to the integral cotangent x dx, which is e to the ln sine x. The integral of the cotangent is log sine, which is e to the log sine x, which is sine x. So we multiply through by sine x. We get sine x times y prime plus, now sine x times cotangent. Cotangent is cosine over sine. So sine times cosine over sine is just cosine x times y equal to 2 sine x cosine x. The left side is sine x times y prime is 2 sine x cosine x. You can check. First derivative second plus second derivative first. Okay, so that means sine x times y is the integral of 2 sine x cosine x. How do you do that?
Can we just double x
Huh?
just sine 2x, just double x formula and integral of sine?
I guess I'll do it that way. But there's another way. We want to integrate. Let me write it down again. It's the integral 2 sine x cosine x dx, which is the integral sine 2x, right? 2 sine x cosine x is sine 2x. Right? You had trigonometry in high school. You know that. We've used it ever since. Or, you know, we want integral 2 sine x cosine x. You can put u equal to sine x du cosine x dx. You can do it by substitution. Either way, right? And it's perfectly all right. You pick one and do it. Okay, I do this one. This is the integral of sine 2x is minus 1/2 cosine 2x plus c. And so we get, let me add a page here so I have more room. What we get is y equals, well, sine x times y is minus 1/2 cosine 2x plus c. So y is minus 1/2 cosine 2x divided by sine x plus c divided by sine x. Here is the general solution. Now, we had an initial value problem, so I have to plug in the initial condition. Y at, I think it was pi over 2. Wasn't it pi over 2? I believe it was pi over 2. It could be 3. So y at pi over 2 is minus 1/2. 2 times pi over 2 is pi. The cosine of pi is minus 1 divided by the sine of pi over 2 is 1 plus c. And we want that to be 3.